This had to be for bragging rights, because if they were really trying to blend in, what they would have done is created something else that did not say SHAI HULUD.
Look, you want to be elite? You got to do it righteous now.
It's going wild in here. I'm pretty sure over 500 packages by now, because when I saw a video that was recorded yesterday by Matty J, he said it was up to like 477. So, I mean, it's been a minute. Let's go ahead and kick it off, because I've been dying to cover this, and I haven't had a good chance to come through and really dig deep into it. And I didn't want to also kind of spoil myself. Now, I couldn't help it a bit. While I was on vacation, I was keeping track of what was happening on Twitter. But other than that, I haven't been digging super deep into what happened with the NPM stuff. So I've been really dying to dig into this one. So I went ahead and I kind of organized a bunch of stories so we can try and form a little bit of a coherent timeline to it. What happened here is, starting September 8th, so this is, who's this blog from? This is the blog from Makaido. And this was just talking about the NPM debug and the chalk packages have been compromised. I know it's hard to see here, but that's what they were saying. So this was the first report on the 8th. And what happened is, Makaido's intel feed alerted us to a series of packages being pushed to NPM, which appeared to contain malicious code. And there were 18 very popular packages. Now, I was curious about this because if you're not familiar with how NPM packages work, there's packages for just about anything, and they're tiny and they're all managed by different people, and any one of them could be an infection vector. And some of them get just downright ridiculous. So one I'm going to pick on here is this one, color string, right here. 27 million downloads a week. What does color string do? Color string is a library for parsing and generating CSS color strings. That's it. Yep. People going and downloading a whole package to handle that CSS color. It's ridiculous little things like this. There was even a package on NPM called is even, where you would check to see if a number was even. And I was like, if you don't know how to do that without adding an additional package and whatever dependencies come with it, you need to not be a programmer at all. So let's take a look at these together here. But spoiler alert, this attack wasn't actually targeting endpoint systems. This was targeting developer systems. And we're going to get into that here in just a minute. So altogether, from the initial infection of this set here, there were more than 2 billion downloads a week. The packages were updated to contain a piece of code that would be executed on the client of a website, which silently intercepts crypto and Web3 activity in the browser, manipulating wallet interactions, and rewrites payment destinations so the funds and approvals are redirected to an attacker-controlled account without any obvious signs to the user. They actually did this in a fairly interesting way too. And the above packages all started having new versions released. For example, for Arrayish, it got a new version released, published, in this case from the screenshot about an hour ago. And we see that the index.js is modified and contains some obfuscated code. Right here. I wish we could scroll over and see this, but there's code in here that just looks this right here, this constant. Like, this is not something standard you would want to see in most programming languages. There better be a damn good explanation if you're going to see code that is not easily, readily accessible. After doing a little bit of deobfuscation, what happened here is you got this pretty complex code block doing a bunch of checks in here. And I mean, it's still not completely deobfuscated. You see this? It's still checking all these different methods and functions that are happening as it comes through here. But one thing that's really interesting is part of this is a whole bunch of strings here. And if I remember correctly, let's see. Yeah, a lot of these were meant to be placeholders for different wallets. Because you gotta remember, the whole purpose of this attack was to try to intercept crypto payments that were happening inside the browser, like say through MetaMask or anything else like that. Heard they got 2 cents out of it. Actually, I think the last check I saw, they got about $1,000, which is absolutely pathetic. But let's keep going before we spoil on this. So the malware is essentially a browser-based interceptor, hijacks both network traffic and application APIs. It injects itself into fetch and XML HTTP requests, which are real common for sending traffic to and from a web server from JavaScript, and common wallet interfaces. It silently rewrites the values in the requests and the responses. So those values are going to be whatever the destination wallet is. So that means any sensitive identifiers such as payment destinations or approval targets can be swapped out for the attacker-controlled ones before the user even sees it or signs it. And it makes the changes harder to notice because it has a string matching logic. So all these strings that were happening in here, what it's doing is it actually has, I'm not going to find it in the code here, But there was string matching logic that said, hey, go find a wallet address, because these are a bunch of pre-computed ones, that is as close as possible. I think it's using the Levenstein distance to one of these strings. So it looks, if you don't pay very close attention, or you just check like the first couple or the last couple, which admittedly I do that, it'd be real easy to just glance over it and not pay attention to the wallet address. So that was actually a really interesting twist on this. I've never seen a piece of malware do that or try to obfuscate itself in that way. What makes this dangerous, though, is it operates on multiple layers. So alternating content shown on websites, tampering with the API calls, and manipulating what users' apps believe they are signing. So even if the interface looks correct, the underlying transaction can be redirected in the background. So here's the step-by-step breakdown. So it injects itself into the browser, hooks a bunch of the core functions, or maybe even wallet APIs like the Windows Ethereum. It ensures that it can intercept the traffic and wallet activity. Watches for sensitive data by scanning the network responses and transaction payloads for anything that looks like a wallet address or transfer. Now, it's actually not checking necessarily the network responses. That makes it sound like it's sniffing the network. What it's doing is it's just watching the traffic and the requests, the types. Recognizes multiple formats across Ethereum, Bitcoin, Solana, Tron, Litecoin, and Bitcoin Cash. It rewrites the target, like we were just talking about, replaces the legit destination with an attacker-controlled address, using a lookalike address via some string matching. And then what it does is it hijacks the session before it gets signed. So it alters Ethereum or Solana transaction parameters. Even if the UI looks correct, the signed transaction routes the funds to the attacker. The way it does it stay stealthy, it says if a crypto wallet is detected, it avoids obvious swaps in the UI to reduce suspicion. That's crazy. And it just keeps silently hooking the background. So how did the guys even get to this point? How did these packages even get here? Well, good old phishing emails. It's always a good phishing email. And let's break down this email because actually it was fairly well done. However, there's a little bit of a catch to it here. And I'm going to explain to you how I handled these kind of situations. This looks legit. It looks like it's a message from NPM. Now, one of the dead giveaways is this is npmjs.help, which is not the domain NPM sends from. But if you're just reading real fast, you might overlook this. But let's look at the other telltale signs if there are. So it says, hi Quicks, part of our ongoing commitment to security and safety, we require you to update your 2FA. Our records indicate it's been over 12 months since your last 2FA update. One big red flag is, unless you're using an insecure 2FA method like maybe SMS, text messages, nobody's going to force you to update your 2FA. If you've got a TOTP, you're good. If you've got a passkey, you're good. There's no reason to have this. Or if you've got a push notification app like GitHub, if you got GitHub, nobody's going to care. They've already got a 2FA system in place. It's one of those, if it ain't broke, don't fix it kind of situations. So that should have been the first thing. Expired passwords? Yes. Expired 2FA? Nobody rotates 2FA. So that should have been the first red flag here. And they say, to maintain the security and integrity of your account, we ask you to kindly update this at your earliest convenience. Please note that without updated 2FA, your credentials will be temporarily locked starting September 10th, 2025. So this email was sent on the 8th. So what they're trying to do here is spark that sense of urgency in here. But they did something smart though. They sent it for the 8th and they said, oh, by the way, you've got 2 days to get it taken care of. So it's not like, oh, I'm about to lose my access right now. Because if you make these phishing emails too urgent, then it's going to start raising suspicions. So that was actually a smart move by their part. I mean, there were several smart moves in here, but that one was particularly good from a psychological standpoint. It tells them, yeah, you got to do this quickly, but not super quickly. So you give them a little bit of time to maybe think it's not a rush job. Now, here's the kicker though. Update 2FA now. The thing that this guy should not have done is click that link. What are we always saying in all the phishing trainings? Don't click the link in the email. This guy's an NPM package developer. He knows how to go in and sign in and handle his stuff. Anytime I get emails like this from any company, bank, social media, GitHub, whatever, I never click the link. I always go log in directly to the interface where I know the address, and then I go find what it's referencing. That's the way I do it. That's what got him right here. He went and logged in, boom, his account got compromised. So the domain was registered just 3 days ago on September 5th, 2025. Look at that. Name server, porkbun.com. That's funny. All right, so let's take a look at the maintainer's response. So this is essentially how the world kind of became aware of this. So after Akaido noticed the maintainer on Blue Sky, he replied, he was aware of being compromised. So he gets a message out here saying, hey, your NPM account seems to have been compromised about an hour ago. He says, yep, I've been pwned. That was it. 2FA email that looked really legitimate, only NPM affected. I've sent off emails to NPM for help with this. Can't get access. Sorry, everyone. Sorry. We're sorry. I'm not gonna clown this guy too much because that was a good-looking email. His biggest mistake was clicking the link, not just going directly to where he knows he should already have the login stored. So the officer also shared that the phishing email was sent from the particular address we saw above. It says, I have no access to my account at the moment. It's in NPM's hands. Syndra has already booted me off and published over chalk. Debug and color string and color convert are still affected along with many others. So the author appeared to have deleted most of the compromised packages before losing access to his account. So at the time of writing, the package Simple Swizzle was still compromised. Okay, now here's the other thing. The attackers were targeting other maintainers at this point too. At a later time, our system detected another package which was compromised by what appeared to be the same attacker, which was Proto-Tinker WC. This one contained very similar code to it right here, with those obfuscated const values in here. This was just the tip of the iceberg right here, because this was on September 8th. So now, the next article in the chain I kind of found was this one from yesterday, September 15th. So the Control Tiny Color package, with about 2 million weekly downloads, was also infected. And they're dubbing this attack SHAI HULUD. For all my Dune fans, you're going to get that reference. Get this, the malware is self-propagating across maintainer packages. It harvests AWS, GCP, and Azure credentials using TruffleHog, and then establishes persistence through GitHub Action backdoors, which represents a major escalation. So I never thought I'd see the day when there was a worm in a package manager, but that's exactly what these guys have pulled off. Let's just jump to the technical analysis because we kind of know what's been happening with this. So the attack unfolds through a sophisticated multi-stage chain that leverages Node.js's process.env for opportunistic credential access and employs Webpack bundle modules for modularity. At the core of the attack, which is about 3.6 megabytes of a minified bundle.js kind of crammed in there, executes during the NPM install, and the execution is triggered via a hijacked post-install script embedded in the compromised package.json. So if you never looked at the contents of a package.json in NPM or any node package, you actually have the ability to run pre and post install scripts. And they are scripts right there. You're trusting that the package manager has written something that is legitimate and necessary to the operation of the package. There actually are command line switches in NPM that you can tell it, hey, don't run pre and post installs in there. But for the most part, nobody really deals with that. So what happens, it goes and gets installed and the post install script comes and runs. The self-propagation engine for the malware includes a self-propagation mechanism through the NPM module update package function. And this function queries NPM's registry API to fetch up to 20 packages owned by the maintainer. Then it force pushes patches to those packages, creates a cascading compromise effect, recursively injecting the malicious bundle into the dependent ecosystems across the registry. And I was watching Matty J earlier today on his live stream, and he had the best explanation for that. You remember the old MySpace worm? That is kind of like that again. Back, everything that's old is new. You don't see many worms these days. Wormable exploits have gone the way of the 2000s. You just don't see them very much anymore. Maybe since the days of Stuxnet. But yeah, this one sure was. All right, so how are they doing the credential harvesting? So the malware repurposes open source tools like TruffleHog to scan the file system for high entropy secrets. So it searches for patterns for AWS using regex. Also, the malware dumps the entire process.env, capturing transient tokens such as the GitHub token or the AWS access key. For cloud-specific operations, malware enumerates AWS Secrets Manager and uses SDK, pagination, and access for GCP via the Google Cloud Secret Manager API. The malware specifically targeted these credentials: GitHub personal access tokens, which is what developers use when they need to access something and keep a token stored on their system; AWS keys, GCP service credentials, Azure creds, any cloud metadata endpoints, and NPM authentication tokens, this is really the one they were primarily after because then they could create that wormable effect. Let's look at the persistence mechanism. So the malware establishes persistence by injecting a GitHub Actions workflow file via base64 encoded bash script. Workflow triggers on a push event and exfiltrates repository secrets to a command and control endpoint. So basically it was set up to go to a webhook on the internet that was listening for this traffic to come back in. The malware creates branches by force merging from the default branch using GitHub's GitRefs endpoint. The data got exfilled. Maybe I gave away a little bit of the plot here. Once the malware aggregates harvested credentials into the JSON payload, which is pretty printed for readability. Oh, how nice. It then uploads the data to a new public repository named SHAI HULUD via GitHub's user repos API. The entire attack design assumes Linux or macOS execution environments, checking for the possibility. That's interesting, actually. I had not heard this piece of information, that it's only targeting Linux and Darwin, which is Mac, if you didn't know that. It's kind of interesting. I guess they're assuming real devs don't use Windows. Like, I use Windows all the time. Then again, I'm not a real dev. I'm a sloppy dev. The entire attack design assumes Linux or macOS execution environments. It deliberately skips Windows systems. For a visual breakdown, the attack flow diagram below. You know, actually, come to think about this, before we go to the attack flow diagram, I wonder if they specifically avoided Windows to avoid EDR. I wonder if they had something in there that maybe they had tested and they knew it was going to flag against something. That would be one of the primary reasons I could think for this, is to avoid EDR. Because I'll be straight with you, EDR on Linux, trash. EDR on Darwin, trash. Anyway, let's go to the attack flow diagram. The bundle loads the NPM install trigger, checks for the OS. If it is not in the OS, exits. If it is in the OS, then it's going to do parallel recon with the promise all. So it's going to check GitHub auth, NPM tokens, AWS and GCP, and then it's going to run Trufflehog to start scanning the file system. That's why. If you start running Trufflehog on any Windows systems with any half AV, you're going to get flagged. That's why they're not targeting Windows, is because of Trufflehog. So they build the payload for the JSON, they give sysinfo, the environment, and the modules. If they've got GitHub auth, then we do no. If they do, then they post to the user repos SHAI HULUD, and bam, exfil it. You can run local repository mirrors and then pin the versions, something like NPM though, since there's so many packages. And that's actually one of the things that I was thinking about for remediations on this, Wolf. And another thing you could even do is just go pin the commit that you're using in the repository. So you're not updating all the packages. Now, the problem is though, is you get this cascading effect whenever you work through all these NPM packages, right? So what happens here is, let's say you import one package. So, we've got package X, right? Well, then package X can come down and it can depend on a whole bunch of different packages there. And then each of those can depend on a whole bunch, right? So now let's say we've got A, B, and C. And this one depends on maybe a different version of A, right? So now these two have to kind of coalesce to figure out which version is going to work in here. We don't know. And then it just makes this long cascading tree. So the problem is, let's say down here in, I don't know, number 3, let's say we've got Q right here. Q is the one that got compromised. Well, then now it's just going to flow up into this package. And heck, even one of these other ones, they could have subdependencies upon subdependencies. It just becomes a freaking nightmare. So as soon as one of the subdependencies gets compromised, it just flows up the chain here. And if one of these doesn't have their dependencies set properly, with like, instead of saying use the latest version, doesn't have a pinned version, then you just kind of beat at that point. All right, let's look at the attack mechanism. So the compromise begins with a minified JavaScript bundle. It gets injected into the affected packages like TinyColor. It's not a rudimentary malware, but rather sophisticated modular engine that uses Webpack chunks to organize OS utilities, cloud SDKs, and API wrappers. Like I said, it looked fairly chunky from just the tiny bit they deobfuscated. The payload imports 6 core modules, each serving a specific function in the attack chain. Let's see if I can bring this up some more. Let's see. So it looks again for which platform it's on, and then it just runs through the modules. So it checks the authentication modules, credential harvesting, scan the file system, propagate by updating the other packages if it can, inject into GitHub workflows, and then exfil everything, creating the SHAI HULUD dump. So for OS Recon, the module calls get system info to build a comprehensive system profile containing the platform's architecture and raw data. It dumps the entire process.env, capturing any sensitive environment variables like AWS access keys or GitHub tokens or anything else that's just existing in the environment. Now, this is interesting how they're credential harvesting across the clouds. So the AWS harvesting module validates credentials using STS and assume role with web identity command. So these are commands in AWS that you can basically use to send the token and see if you get a valid response back in what you are whenever you're running it. But then enumerates the secrets using the client secrets manager. It does pretty much the same thing through GCP. But then now for the file system scanning, looks at is it spawns Trufflehog via child process exec to scan the entire file system. So notice this, it's scanning like from the root of the system. So it parses the output for higher entropy matches such as AWS keys or things that are just found in common locations. And Let's take a deeper look at the propagation mechanism. So the NPM propagation module parses that NPM token. After validating it, starts receiving what are the 20 top packages that this maintainer has that are owned by them. So this creates a cascading effect when the infected package leads to a compromised maintainer's credentials, which in turn infects all the other packages maintained by that user. Ooh. Now, this is actually the one I was most curious about because I don't have a ton of experience with GitHub Actions, and they were using this as a backdoor to maintain persistence. The GitHub backdoor module authenticates from the user endpoint, requiring repo and workflow scopes. So after listing the organizations, it injects malicious code via a bash script. Here is a reconstruction of the bash script. So we get the token, we create a branch name called SHAI HULUD. We set up the file name, which was the SHAI HULUD workflow. Then in here is where it actually drops the GitHub action. It says webhook site. I believe they've obfuscated that. I don't think that is the correct. Yeah, see, that was the C2 exfil. They curl it. They echo the contents for base 64. I like how they put the note in here, basically for evasion. Double base 64. So secure. And then for the env, their contents is they just run the JSON from the secrets. Let's see what else I got going on here. This sidebar is annoying me. So the repo response is we get the affiliate owner, the collaborator, the organization members, and it checks basically since January of 2025. Let's see. So then it comes through and it reads the repos, checks the branch data, and basically overwrites it if it's existing. So that's how they're setting up this GitHub workflow into the repository. So what they're doing is they're not injecting directly into GitHub Actions. What they're doing is they're taking this file content here, which is the normal definition for the GitHub action, and they're dropping it into the repository. So let's check out the exfiltration. So the malware builds a comprehensive JSON payload containing all the system information, environment variables, and data from all the modules. So it then creates a public repository via the GitHub repos post endpoint using the function make repo. The repository is public by default to ensure easy access for the command and control infrastructure. We are observing hundreds of such public repositories containing exfiltrated credentials. A GitHub search for SHAI HULUD repositories reveals the ongoing and widespread nature of the attack, with new repositories being created as more systems execute the compromised packages. Yeah, look at all this. Because at the time they took the screenshot, which was yesterday, there were 620 of these. Dang. The exfiltration technique is very similar to the NX supply chain attack, where attackers use public GitHub repositories to exfiltrate stolen creds. The pattern of using GitHub as an exfiltration endpoint appears to be a preferred method for supply chain attackers, as it blends in with normal developer activity and bypasses many traditional security controls. The repositories contain a lot of sensitive information. The public nature of these repositories means that anybody can access them and potentially misuse the creds, creating a secondary risk beyond the initial compromise. Yeah, that's what I was like, ooh, this isn't just a sensitive compromise. This is a complete breach. You've gone past the point of an incident and moved directly to breach at this point, because there's zero question about this, because you've gone from, not only did you have solid proof that data left your network, but now you have proof that data left your network and was publicly accessible. You have gone full-blown breach. We're talking like a level 11 breach. So the attackers employ several evasion techniques, including silent error handling, which was handled by a catch blocks. There was no logging output, and disguising the trouble hog execution as a legitimate security scan. They also had runtime analysis with a hardened runner. So we analyzed the malicious payload using Sept Security's hardened runner in a GitHub Actions workflow. Hardened runner successfully flagged the suspicious behavior as anomalous. So the compromised package made unauthorized API calls to API GitHub. The API interactions were flagged as anomalous since legitimate package installations should not be making such calls to the API. Well, good. That is an anomaly. The runtime detections confirmed the sophisticated nature of the attack, with the malware attempting credential harvesting, self-propagation to other packages, and data exfil, all during what appears to be a routine package install. And then we've got various indicators of compromise, searching for malicious repos, file hashes, suspicious API calls, and all the good shebang. Actually, what did they say here for cleaning the infected repos? So remove malicious GitHub action workflows. Well, I mean, this is actually pretty simple because it always had the same hard-coded name, right? The SHAI HULUD workflow. This had to be for bragging rights, because if they were really trying to blend in, what they would have done is created something else that did not say SHAI HULUD. They would have had like a list of pseudo-random names in there that they could have built to go drop in these workflows, something that maybe tried to blend in, but that's a pretty heavy IOC right there. And even though they're targeting Mac and Linux, there are EDR solutions on Mac and Linux. So if you ever saw this get dropped to, actually, I don't think this ever got dropped to disk. I checked that back. This got dropped over into GitHub. But there's also GitHub monitoring solutions. I don't remember them offhand, but I know there are. So this is probably going to get hard flagged for something like that. This is, by the way, this blog post was from Step Security IO. I think that's what they were looking at. Now, there was another one here, socket.dev. I deleted their header in here, but trust me, this is socket.dev. They've been doing a lot of good coverage on this. So I wonder if they have any additional information, because this one's from yesterday. So the other one was from the 15th. This one's from yesterday. Yeah, this one was talking about multiple CrowdStrike NPM packages were published by the CrowdStrike publisher NPM account and were compromised. So it looks like a continuation of the ongoing malicious supply chain attack known as SHAI HULUD that previously compromised a bunch of other packages. The malware is identical to the previous campaign, which included a bundled JavaScript that executed truffle hog, validate, discover CI credentials, all the good stuff we were just talking about. Creating the unauthorized GitHub action I thought was really slick. At this point, I'm thinking they have a mole. You mean, are you talking about CrowdStrike? I mean, they're a big enough company, maybe. Who knows? I mean, I think it's more likely that CrowdStrike just got caught, one, obviously with the massive global meltdown, which if you think about it, completely defeated the purpose of the larger decentralized internet. The entire idea of the internet when it was envisioned by DARPA was to make a nuclear resilient, self-correcting network that was always online. I don't think the creators of DARPANet could have foreseen something like, here's a system and they all download updates from the same thing, because system updates like that weren't a practice back then. It just wasn't. You had to do manual updates, and updates were rather infrequent. They weren't in this incredibly rapid cycle like we have today. But then also, I don't think they ever envisioned that the singular piece of software that was not the operating system would be running on the vast majority of systems across the internet. Yeah, but they're constantly messing up. Now, one thing I find funny is, obviously, CrowdStrike does have a Mac OS agent, right? There is Falcon for Mac. I think that's what it's called. And even that didn't, catch any of this. It didn't catch Truffle Hog running on the Mac, if that was the case. So they either have two options here. So the developer at CrowdStrike was either working on Linux box, which I don't know if CrowdStrike has an EDR for Linux. Sentinel-1, I'm pretty sure does. But they were either working on a Linux box with no EDR, or maybe working on Mac that did have the CrowdStrike EDR. They probably got hit by the propagation, and then during that process got compromised. So then that doesn't speak very well for CrowdStrike on Mac, because this should have been fairly detectable, right? Let's take a look at this real quick. The affected packages were quickly removed from the NPM registry. The malware includes a workflow file named SHAI HULUD, a nod to the sandworm in Dune. SHAI HULUD. So while not a unique reference, its presence reinforces the attacker's deliberate branding of the campaign. In our previous analysis, we found the payload writes a GitHub action workflow. Around the same time, nearly 700 public repositories titled SHAI HULUD migration appeared on GitHub. So while the precise role of these repos is still under investigation, the naming and timing suggest they may be artifacts of attacker automation used to persist for a stage of the workflow. So in our previous post, we had further details on the malware itself, which we're good, we already talked about that. But the bash block uses a GitHub personal access token if present, writes a GitHub action workflow, and exfiltrates the collected content to a webhook. So the script combines local scanning with a lot of popular tools. We kind of already talked about that. Oh, good. So they've got a little bit more of a timeline here. So on September 14th, they observed the first compromise. So it looks like the one from the 8th was similar, but not exactly. Like they were not necessarily related to one another. I don't see exactly how they were interconnected. Perhaps, actually, I don't think they were interconnected at all, because there was no indication that the September 8th compromise led to any kind of remote code execution. It was just injecting into the package. So unless they have changed something, or maybe in some way use that backdoor access to come through and start propagating this stuff, this appears to be a second attack. I don't know if it was from the same attackers or not. But basically, they first observed the SHAI HULUD variant on September 14th. A couple of these repos got hit. There was a small burst, again, about an hour later. And then the first large burst with about 25 additional packages. Another roughly 16 happened. So this is a short time frame, right? So at 17:58, and then not even, 37 minutes later, there was another burst. And then from that, about 56 minutes later, another big burst. After this one, it was only about 16 minutes where we saw another group of packages get hit. Starting on the 15th, again, burst, new hash type appeared. We observed a reuse of all these different types. This is on the 15th. There's just more packages getting compromised. And then on the 16th, that's when CrowdStrike got hit. On the CrowdStrike CLI, if I remember correctly. So after CrowdStrike got hit, there was, again, another burst, previous hash returns, and then we had a bunch of other ones. So the threat actors created separate different versions of the worm, which we know because the worm has no ability to edit itself. There were multiple different seeder events as well as bursts from previous worms, as evidenced in the timeline selection. So that's what they were talking about. Every time there was a new hash observed, they tweaked it. They gone through and modified it a bit. So they basically restructured it. They're tweaking this as it's actually out propagating. That's still really neat. So clearly there's a post-install script called Node.js. Actually, hold on. This is great because this is the package.json here. So where you see the script section here, and anytime you download a Node package, there's a package.json file in there, and it will dictate a lot of the information. So it's a good place to go find things. One thing I actually find on a good number of penetration tests when I'm doing tests is sometimes they will accidentally ship the package.json to the web server. So a lot of times the web front end and all of its interactions are built in Node, and sometimes they'll accidentally ship the Node.js. And it doesn't provide a ton of great information, but it does help you paint a little bit of a picture of what's happening inside the documents. Like, for example, if you see, they're using JSON web tokens, that's not a big deal. But all these other things like, okay, it's written in TypeScript. So it does give you some extra information. This is not a great example of that, but you see it. But here is the post install right here. So what happens is after the package gets installed, it runs this bundle.js that got added. All right, so looking at this again, so it says clearly there's a post install script from that bundle.js in there. And the tarball injection ensures that the malicious code is present in the artifact itself. It's hard to notice if the downstream user is just doing an NPM install for the package. So adding the post install script ensures automatic execution during the install, even if the package normal runtime doesn't import the injected file. So this also explains why certain hashes reemerged. It may not be because the threat actor decided version 5 or 6 were superior, but actually because those versions found other accounts to propagate through. The GitHub action workflow triggers on events not continuously, which would explain the gaps in time between the burst from the malware. So this indicates that we've not seen the last of this malware yet. The best is yet to come. And they go through some immediate guidance like uninstalling certain versions, auditing your CI/CD, things like that. But look at this, compromised packages and versions. Keep scrolling. Come on, keep scrolling. Yep, I was right. It's over 500 now. It's over 500! Doesn't have quite the same ring as over 9,000, but this is definitely an interesting attack. And especially for it to come so close to the September 8th attack, which was just the crypto bros in there trying to get their crypto thing on. I think last time I checked that, they only made about $1,000. There was something more going on here. Especially given the fact that they were publishing all this information here, this almost to me feels like it was not intended to cause mass compromise. It did, but I think that was a secondary effect. Looking at all the effects of what happened and its propagation and the naming of it, calling it SHAI HULUD, and then also making those public repositories in there. I think this was more a case of someone trying to either brag, basically saying, hey, look at me, I want cool hacker points, which they get because this was pretty cool. Or two, they're trying to target specific ones and they don't want to know which ones got compromised. And so by everything being public and being able to go view it publicly, they can hide inside the noise that they've created